Right, in this video, we are going to learn how we can actually transform a non-linear equations to a linear form. Right, so with some manipulations, certain relationships that are not linearly related can be transformed to a linear form. But first of all, let's try to understand what is a linear form. Right, so basically, a linear form is such that the equation may be represented by a straight line. Then the next thing that we need to ask ourselves is, then what are the properties of a straight line? Right, so a straight line can be expressed in the form y equals to mx plus c, where your m represents the gradient of the straight line and c represents the y-intercept value. So if you have a straight line with a positive gradient, this is how it looks like. And the value here on the y-axis is the value for c. It's a constant. Constant meaning it is a number. It can be a rational number. Yes, it can also be an irrational number. Just basically, a constant is just a number. Right, so there are some examples of a straight line. The first one is the one having a positive gradient. The second one is one having a negative gradient. Right, the third one is a vertical line where you have undefined gradient. And the fourth one is a line that have zero gradient. All right, so where are your y-intercept value then? So for the first graph, the y-intercept value is this value here. Your c is the value there. The second one is here. All right, for the third one, you don't have any y-intercept value. So for such straight line, you usually describe the line as x equals to a, where the a is the x-intercept value. And for the last one, right, this will be your value of c. So to describe that horizontal line, it's just y equals to c, where your c is the y-intercept value. So it's can be -1, can be 2, can be 4, any rational numbers. Can also be an irrational number. All right, let's do some example. If you look at the examples that is being presented on the screen, we have 3 equations there, right? So which equation is represented in a linear form, in a linear manner, which it's not? So let's examine. So to be in a linear form, basically, it must confine to y equals to mx plus c, where c is a constant, right? Constant. So constant is just a rational number or just a real number. Okay, we'll put it real number. Real number comprises of rational and irrational. So constant is just a real number. All right. So if you look at the first equation here, okay, the letter b here is actually your constant. Can you see there's no variable? Variables are represented, usually variables are represented by the letters x or y. Right, so for the first equation, all right, that's a constant b, which actually, if you were to compare it with your y equals to mx plus c, your b is actually the y-intercept value. So in this case here, this is a linear equation. So this guy is a linear equation. But if you look at the second one, right, you will observe that there is no constant. This is a variable. This one is also a variable. Even though A is a constant, but you're multiplying with a variable, right? So it ends up being a variable also. Likewise, B is a constant, but B divided by a variable, this thing means it's a variable. So hence part B is a non-linear form. And if you look at part C, right, x times y, that's variables. B times x, that's a variable. And A divided by x, that's also variable. So the third one is also a non-linear. Right, so the next question is, what skills are we going to apply to convert your non-linear form to linear form? Let's look at part A first. Right, so as what I've explained earlier on, B is a constant. So I have a constant there, so hence this is a linear form. And if you were to represent it graphically, right, if you were to compare it with your y equals to mx plus c, then on your x-axis, right, is the value 1 over x squared. On the y-axis is y. All right, so if your A is a positive gradient, if A is a negative gradient, then this is how the line would look like. And if your B is a positive value, right, that the one that I've highlighted there, that will be your y-intercept value. Or it can be represented this way. The second way showing that M is a positive gradient. And this point here will be your y-intercept value, which is the constant B. Right, then how do I manage to get this value on the x-axis? Right, so we have to do some manipulations to this linear form. We have to write it in a form y equals to mx plus c. So basically, you just factorize. That means you put the value for your gradient beside the value that you need to label on the x-axis. Right, then you compare it with your y equals to mx plus c. Right, so you can see that m is the gradient, which is equals to a, and b is the y-intercept value, right, which is comparable to c. And what you label on the x-axis will be 1 over x squared, and what you label on the y-axis will be just the letter y. All right. So what we're going to do next is that we're going to apply some skills to convert part B to linear form. So I'm just going to multiply every terms with square root x. And let's see what happened. All right, so when I multiply every term with square root x, I managed to get a constant b. Okay? So once I've achieved that, that means I know that what I've gotten is in a linear form. Because you can actually compare it with y equals to mx plus c. Right, so on the y-axis, it will be y square root x. On the x-axis, it will be just the letter x. And here the gradient will be represented by the letter a. And the y-intercept value will be b. the examples I've given you, it's if the gradient is a positive value. Right, if it's negative value, or if you have a negative y-intercept value, then it will be a second diagram that's as shown. Right, so let's look at the third example. How do I convert that into a linear form? So remember, the objective is to do some manipulations until you manage to get a constant. Meaning you manage to get just A alone or just B alone without anything else. It's just A alone or B alone. And then we stop the operation. Right. So what I've done here is I'm dividing every term with X. And let's see what happened. Here, so if you divide it every term with X, you end up getting Y equals to A over X squared plus B. So here your B is a constant term really, so we can stop it and we can rewrite it in the form. Compare it with the form y equals to mx plus c. So what you'll be labeling on the x-axis will be 1 over x squared. What you label on the y-axis will be the letter y. The gradient will be a, and the y-intercept value will be b. So I've drawn two different kind of straight line, one with positive gradient, positive y-intercept, and one with negative gradient and negative y-intercept. It can also be in this form, negative gradient but positive y-intercept. It doesn't matter. Okay. As in, it depends on the values that you get for your A and B. Right, let's do another example. Right, so if you observe that the equations given, there's no constant term. Right, every term there has a variable. First one is x, y, two variables there. Second one is a divided by a variable x plus the third one is b times another variable. So hence there's no constant term at all. Hence this is a non-linear form. Right, so there are two ways of converting it to a linear form. I can just multiply, I can just divide by x throughout. Right, and I'll end up getting y equals to a over x squared plus b. So I stopped doing anymore because I managed to get b here, which is a constant. And if you were to compare it with, yes, you would have to pull your a out of your 1 over x squared, because you have to compare it with y equals to mx plus c. Okay, if you were to observe, the m is the gradient, which is the coefficients of x. Hence, what we need to do is you will have to rewrite it, make it such that a is clearly observed as the coefficient of 1 over x squared. Right, so in this case here, if you're going to draw a sketch graphically, then on the x-axis, you'll be labeled 1 over x squared. And on the y-axis, you'll be labeled as the lowercase y. And if you're talking about a positive y-intercept value, this is how it looks like with a negative gradient, or it can be a negative gradient with a negative y-intercept. It can be a positive gradient with a negative y-intercept, or positive gradient with a positive y-intercept, depending on the values of a and b that you're given. All right, there's another way of converting the non-linear to linear form. In this case here, right, we're going to multiply every term with x. Right, so you can actually apply any methods as long as the final products that you have contains a constant. So if you look at method 1, the constant is the letter B. If you look at method 2, the constant here is your letter A. And once you have achieved a constant, you just stop the operation. And then you just compare it with the straight line equations, which is y equals to mx plus c. Right, and graphically, it can be represented in this way. If you're having a negative gradient, your gradient here will be the letter B. And if you have a positive y-intercept, which is represented by the letter A, this is how the straight line equation will look like. Then on the x-axis, it's no longer the letter x, but it's x squared. Then on the y-axis, it's no longer the letter y, but x squared y. All right, let's try to do another questions. Right. So you're given x equals to bxy plus ay. Right, so again, this is a non-linear form. It's basically, there's no constant there. Right, it's all the variable. X on the left-hand side. bxy, b is a constant, but you're multiplying it with xy, so that makes it a variations of constant and variable. So we take it as it's not a constant. And then a times y, although you have a meaning a constant, but you're multiplying it with y, so a times y does not make it a constant. A constant would just be a alone or b alone. Right, so method 1, what do we do? So if you want to make a the constant, then you can just divide both sides, every terms with the letter y. Right, so here you can see that I've managed to just extract the constant a out. So we can just stop doing and then compare it with your y equals to mx plus c. Right, so if you were to represent it graphically, on the x-axis, you will label the letter lowercase x. Then on the y-axis, it will be x over y. So if you have a positive gradient b, so b is your gradient. If your gradient is positive, then probably your straight line will look in this way. A is your y-intercept value, and then your gradient is the constant b. So that's method 1. So method 2, it's if you want to make b the constant instead, then you will just have to divide every term by xy. All right, then you rearrange it. Okay, rearrange it to make a the coefficients of 1 over x. Right, and you compare it with your y equals to mx plus c. And if you were to represent it graphically, right. So what do you label on the y-axis? That will be your 1 over y. And what do you label on the x-axis? That will be 1 over x. And if you have a positive or that have a negative gradient, right, so your gradient is represented by the constant a. If you have a negative gradient and a positive y-intercept value, this is how your straight line graph will look like. Right, let's try another different types of questions. You're given two fractions on the left equals to 2. I think many of us would be very tempted to combine the two fractions into one. That's okay, we can try to do that. So the common denominator will be x times y. So we will have to take x multiplied by y at both the numerator and the denominator, and you will get ay plus, if you take y times x at the denominator, also at the numerator, you would end up getting bx equals to 2. Right, I would advise you to make 2 as 2 over 1. And then the next step, naturally, you would do a cross multiply, so that you will get 2 multiplied by xy gives you 1 multiplied by ay plus bx. That just gives you ay plus bx. All right, so remember our objective. In order to convert it to a linear form, we just need to make sure we have a constant. It can be just a alone or b alone. So now we have to make up our mind. Which constants do you want? Do you want a or you want b? Right. So if you want b to be the constants that you're looking for, then we'll just divide by x throughout. Right, and then you will have 2y equals to a y over x plus b. All right, so we can't actually have 2y on the y-axis, because if you were to compare with y equals to mx plus c, the one on the y-axis can be just y alone or x alone or combinations, but you can't actually have 2y. So what we're going to do is going to divide again throughout by 2. So 2y divided by 2 will just give you y. Then ay over x, which I'm going to show it to you, the working here, ay over x divided by 2 will just give you ay over x times half. And that gives you half times ay over x. So that is half times ay over x, then plus b over 2. I think it's all right to have b over 2. If b is a constant, b divided by 2 will also be a constant. So that's okay. We can leave it as like that. The next step then is to rearrange it into the format y equals to mx plus c. We have to rearrange into mx plus c. So you would get half a bracket y over x plus b over 2. Okay, right. So if you do a comparison with your y equals to mx plus c, then, and if you were to represent this graphically, so on the y-axis, it will be just the letter y. On the x-axis will be y over x. And then you will have gradient, depending on whether your gradient is positive or negative. Okay, I'm just going to randomly draw a straight line like that. Your gradient, which is the symbol m, is equals to half a. Then this y-intercept value is b over 2. So this is one way of doing it. So supposing you don't quite like it, right, then what is a second method? Right, we can continue from here. 2xy equals to ay plus bx. So supposing you want to make a the constant. You want to make a the constant. So you just divide by y throughout. Right, and then you end up having 2x equals to a plus bx over y. Okay, so we're going to divide by 2 throughout again. So you have a equals to bx over y divided by 2, will gives you bx over 2y plus a over 2. Okay, we're going to factorize b over 2 out. Make it the coefficients of x over y. Okay, then you compare it with your y equals to mx plus c. So graphically, this is how it looks like. On the x-axis will be the variable x over y. On the y-axis will be x. Right, I'm just going to randomly draw a straight line. Depending on the gradient, whether positive or negative, the gradient will be the values for b over 2. And this y-intercept will be a over 2. So this is another way of expressing the given nonlinear equations into a linear form. All right, let's do another questions. Right, this one is very different from what we have done previously. Right, this is different because you have y equals to a times x to the power b. What we have done so far is y equals to a plus. The operation is something plus something. Y equals to something plus something, or x equals to something plus something. But now you have y equals to a times x to the power b. You have a power here. So which law actually allow you to able to bring the power, bring the power, from right now your index, the power is b. Which law actually allow you to bring the power to make it the coefficients? Yes, in the we learn logarithmic functions. So logarithmic functions is the only functions that allow us to actually bring the power to become the coefficient, right? So to apply the law, we would have to bring common log, which is LG, or natural log, which is Ln. All right, so if you bring LG to both sides, okay, recall, we learned this earlier on. If you have log m times n, this will give you log m plus log n. So this will give us log a plus log x to the power b. Oh, I forgot my y here. Let me write it properly. Right, so this is what I mean, that you can actually bring the power to become the coefficient, applying the power law. Okay, power law is this guy here that we're talking about. So you will get log y equals to, I'm going to shift the position, put log x to the power b as the first term. So when you bring the power down, you'll be just b log x, then plus log a. Right, so if a is a constant, then log a is also a constant. If a is 2, log 2 will be a constant. Log 3, log 4, whatever will be constant. So therefore, what you're having here is a constant. So if you were to compare it with your straight line, the linear form, y equals to mx plus c, right? And then if you represent it graphically, can you see that on the x-axis, it will be log x. On the y-axis, that will be log y. And then if I just draw a random straight line, the gradient will be the letter b. And this value here would be your y-intercept, which is log a. So what happens if you don't want to use common log? If you use Ln, natural log, right? The steps are still the same. And the values for the gradient ultimately and the values for the constant a ultimately will still be the same as well. All right, so whether you bring common log to both sides or natural log to both sides, you should still, you will get the same answer for gradient and also the same answer for values of a. That means the values of b and a will be the same. Right, let's do another questions. So this questions here, it's a combinations of what we have learned earlier. That means you have y equals to something minus something, or y equals to something plus something. But it also involves ax to the power b. Where if you were to recall in the earlier slide, if you have, we did something like y equals to ax to the power b, right? You have to apply the logarithmic functions so that you can actually bring the power to be the coefficient. Right, but I think many of you will be tempted to do it this way. I'm going to show you. Right, so if you do it this way, then then you'll be at a deadlock because you can't actually apply any logarithmic laws. There is no such a law. You don't have this at all. What you have are, if you have log n, m times n, must be m times n, then that will give you log m plus log n. If you have a log bracket m divide by n, okay, it's divide. then you can break it up into log m, two separate log m and log n. Or if you have a log m to the power n, right? So these are the three legitimate logarithmic function you can use. All right, there's no such a law here. So as the result, if you do something like this, okay, you will be at the deadlock. Right. So if that's the case, then what is the correct way of doing it? Right. So what we'll be doing is, I'm just going to bring the 3 to the other side. Then multiply by negative throughout. Right. So in this case here, this one here will be something like what we have observed earlier on in the earlier slide. Here, then I can go ahead and bring log or natural log or common log to both sides. So this question is a bit tricky. Okay, and if you compare it with your y equals to mx plus c, and if you were to present it graphically, then on the x-axis will just be your ln x, y-axis is ln 3 minus y, and if I'm just going to draw a random straight line, the gradient will be equals to b, and this value here will be your ln a. Right, so much about converting non-linear form to linear form. Let's do some problem solving. So if you have a question such that y over x is plotted against x, and you have a straight line, right? So you ask to express y in terms of x and sketch the graph of y against x. So there are two things we need to do. We have to find the equations y equals in terms of x, and then using the functions that we found, sketch the graph. Okay. So what is the basic concepts that we've learned? The basic concepts here is converting non-linear to linear. And then what is a linear form? A linear form is one that conform to this general form y equals to mx plus c. So if you look at what you have graphically here, okay, on the y-axis, you can just replace it with y over x. On the x-axis, just replace it with, and we don't know the y-intercept. You can extend this line longer, but we wouldn't know this value, right? It's not given there. Okay, so there are two things we need to do. What are the two things? We need to find the gradient. So finding the gradient is easy because you're already given 2 points there. Okay, you're given 2 points. So you can label this as x2, y2, x1, y1, and you can just easily find your gradient using y2 minus y1 over x2 minus x1. So that will give you 3 minus 1 over 5 minus 3 gives you 1. So gradient equals to 1. Right. So we can actually substitute the gradient into your equation. So the next step is to find the unknown c. So what you can just simply substitute either 5, 3 or 3, 1 into equation 1. So in this case here, we can use 3, 1 or 5, 3, but I'm going to use 3, 1. So I'm going to sub that into equation 1. So I will have 1 equals to 3 plus c. So c will be 1 minus 3, that's negative 2. So therefore, the equations you get will be y over x equals to x minus 2. This will be your equation for this straight line. Alright, so you need to express y in terms of x. So to make y the subject, you just multiply every term by x throughout. So you will have x squared minus 2x. Okay, so how do we sketch this graph? So y equals to x squared minus 2x is actually a quadratic curve. It's a quadratic curve. So for quadratic curve, we need to know whether it's a U shape or the N shape. So the coefficient of x squared is 1. So this is a U-shaped curve. And then if you let x equals to 0, y will be 0. So it will be in this form. Oh no, it's not. Because we need to find the x-intercept. Okay, I'm being too ambitious. Let's do it at the next slide. Right, so to sketch this quadratic curve, we're going to find your x-intercept and your y-intercept. So if I'm going to let x equals to 0, then y will be 0. So you have one point that is 0, 0. If I'm going to let y equals to 0, so x squared minus 2x equals to 0, factorize your x. So the x-intercept is x equals to 0 or x equals to 2. Right. So this is a U-shaped curve as what we have said earlier on. So I have one point here. I have also another point here. Okay, and if it's a U-shaped curve, it will go this way. Right. I don't have to find the minimum point. It's not stated in the questions. Right. It just gives a sketch. And this is how we do it. All right, let's do another questions. Okay, you're given a straight line. So let's go back to the basic. So the basic is your y equals to mx plus c. Let's fill in the values for y here, which is y over square root x. The gradient we wouldn't know. We're going to find later on. And then on the x-axis is x squared. Y-intercept we wouldn't know also. We're going to find later. All right, so that's my gradient. Gradient is the easiest to find. Just use y2 minus y1. Okay, in this case here then, use the formula y2 minus y1 over x2 minus x1. So I need to remind you that here, your x coordinate is not x coordinate. It has to be replaced by x squared. So the general form for coordinate is actually x squared, comma y over square root x. Okay. So by right, if you want to be very exact, it's actually not y2 minus y1, but rather y2 square root x minus y1 over y2, and then x2. It's not x2, it's just x squared 2 minus squared 1. Right, so we don't have to write down this formula. It's rather confusing. So you just remember that to find gradient, you just take 4 minus 2 over 3 minus 7. That gives you negative half. Okay, so that substitute into your straight line equation. Right, so there are 2 points that you can use to sub into equation 1 to find your unknown c. I'm going to use 3, 4. Right, so that will be 4 equals to negative half times 3 plus c. So c will be 4 plus 3 over 2, 5.5. So therefore, your equation will be y over square root x equals to negative half x squared plus 5.5 is actually 11 over 2. So this is, all right. But if you look at part 1, supposed to express y in terms of x. So I'm going to multiply every term by square root x. So I will end up getting y equals to negative half x squared square root x plus 11 over 2 square root x. Okay, so that's part 1. Then for part 2, find the value of y when x equals to 4. So you just simply substitute x to be 4. And that you will get 16 or negative 16 plus 11 gives you negative 5. Okay, let's do another questions to boost your confidence and the morale. Back to the basic, y equals to mx plus c. So what is on your y-axis is ln y. What is on your x-axis is ln x. Not sure about the gradient yet. We need to find. Not sure about the y-intercept value. The y-intercept value is this guy here, but we don't know what is the value. Okay, let's find the gradient first. So gradient is just 5 3/4 minus away negative 1. Negative 2.5 minus 2. Let's use calculator to work that out. Right, you will get the gradient to be negative 3 over 2. So with that, let's put that into our linear form. Alright, so we are given 2 points there. Obviously, I would use 2 common negative 1 because it's simpler than the one given above, which are both in fraction form. So ln y would just be negative 1. Ln x will be 2, and plus c. So from there, c is equals to negative 1 plus 3 gives you 2. So therefore, the equation will be ln y equals to negative 3 over 2 ln x plus 2. Right, what's the next step we need to do? Find the values of k and p. Right, so in other words, I would have to convert this equation, this linear form, to remove your log, to remove the log and express it in this format here, where I can find the values of p and k from the equation. All right. So if you've forgotten how to manage questions using log, do revise. So what I can do is I would apply the linear law here. This one is your coefficient, right? I'm going to just bring it up. To be the power of x. And then 2, I can actually write 2 as log. Log is, common log LG is log base 10. So that actually gives me log 10 squared. Log 10 squared. Alright, if you have forgotten, you can take the 2 down. So log 10 is 1, so this is just 2. So 2 is actually log 10 squared. Why do I want to do that? So that I can apply my product law here, which I will get log y equals to log 10 squared is 100. So 100 times x to the power negative 3 over 2. And since I have a log on both sides, I can just remove the log. So I will end up having y equals to 100 times x to the power negative 3 over 2. And the story doesn't end here, because if you look at what you're given, I have to make y squared the subject, not y. So I have to square both sides. So square y will be y squared. I need to square this guy. to the power of 2. So I would have 100,000, then x to the power of negative 3. Okay, I need to continue here. So I will have y squared equals 100,000 over x to the power of 3. And if you compare with what you're given, okay, the value of p will be 100,000 and the values of k will be 3. Right, so I've covered enough questions. So for the remaining ones, please do it on your own. You are asked to transform the given equation, that is your part A, B, C, D. Right, transform all these equations to linear form. And then write down the values for the gradient and the y-intercept value. And provide a graphical representation. So you don't really have to, you don't really have to show positive, negative gradient, because we don't know if the gradient given is positive or negative. You just roughly draw a straight line, indicate where the y-intercept is, and the value for the y-intercept, like what I have done earlier.